In this question, we have two circles that are intersecting and they meet. The two equations are as shown. In part A, we had to show that angle AOB was 0.635 radians. And for part B, we need to try and find what the perimeter of this shaded region is. Another thing worth adding is we worked out the equation of the line that goes through AB is x equals 19 over 2. Right, so we know AOB. AOB is 0.635 radians. To work out the length of an arc when you have an angle in radians, you simply have to do the radius times theta. The radius for this one is 10. Okay. Well, if we consider, actually, we can do it in one calculation if we just take that angle there. This angle here will allow us to calculate what the major arc is, and that is the part of the perimeter of this shaded region. So, get the easy bit out of the way and the straightforward marks. We will do the C1 arc length. We know it's going to be r theta, which in this case is 10 multiplied by the angle, which is 2 pi minus 0.635. I'll give the angle of the major arc. Pop that into your calculator and you get 56.48. Okay, so that's the straightforward bit done. Now we've got to look to see how to work out what the length of this arc is. Okay, well, we can do a similar method. Let's get rid of all this working now. We can do a similar method and work out what the angle is here. In order to work out the angle there, we need to work out the angle on the inside. This inside bit is made up of two right-angled triangles, which you should be able to see in there. So if we redraw that right-angled triangle and fill in the points that we know. We know it's right-angled. We know the length here. The length here would be the radius. Radius for this one is root 40. So we've got the length of one side, so we need to try and work out the length of another side. Well, in this case, we can work out this length along here. From the previous part of the question, we found that the x-coordinate here was 19 over 2. We can also work out the x-coordinate here, because it's simply just the x-coordinate of the centre of the circle, which, if we look here, is 15. Because that's 15, we simply just need to do 15 minus 19 over 2, which is 5.5. It's this angle that we need to know, and I'll label that one theta. So using trigonometry, labelling the sides, that one's adjacent, that one's opposite, and that one's hypotenuse, so it is definitely cos theta. Putting that into your calculator, you get 0.5163. Now it's important we don't use that as our angle, because notice that is just half of this whole angle here. So we need to know what 2 theta is. So we double that. Okay. Now we know that one, we can do the same method as we did for the arc length for scene 1. It's going to be r theta again, so the radius this time is root 40 and we multiply that by 2 pi minus this particular value here, because that was the angle of twice of this. Well, into calculator. So to find perimeter of a shaded region, simply add those two together. And to 3 significant figures, you get 89.7. And there you have it.